Hello, my little triglets. It seems like forever since we've been together on this computer screen. Today we're going to cover section 4.1. This chapter is all graphing the sine and cosine and other functions. The graph of y equals sine x is a wave, and the wave is found by plotting pieces around the circle. Let me back up here a minute. So I do want to do this, but I want to do this, and then I want to do this. All right, so we got three things going on here. This is an XY chart, but our Y is sine X. So putting X's in, those are going to be angles. Now I chose a bunch of random, well not random, I guess they're the ones around the circle. So we can kind of see what's going on. And pi. Now, and then I put them into the calculator to get decimal equivalents so we know how high up the circle they go. So sine of 0 is 0. Sine of pi over 6 is 1/2, but I'm going to write it as 0.5. Pi over 4 is root 2 over 2, which is 0.71. Pi over 3 is root 3 over 2, which is 0.87. Pi over 2 is just 1. 3 pi over 4 is another 45, so that's 0.71, just like the other one was above. And then pi is just 0. So what I'm going to do now is go around the circle and mark some of those. Let me fix that. I'll get rid of that, that, and that. And I'm going to do that, that, and that instead. Okay, so 0, 0 is right here. You go over to the 0 angle and up 0. On the ordered, or on the axes here, it's also 0, 0. For pi over 6 and 1/2, that's right here. Let me do that in red. Pi over 6 and 1/2. So I'm going to take that 1/2 and go across. Here's pi over 6, and that height is there. This is pi over 6. Pi over 4 is 0.71. So that distance, if this is 0.5 and this is 1, so 0.71 if I go straight across is about here, that height. That's at pi over 4. Pi over 3 is 0.87, so that's getting up here. So that's almost to 1, so it's approximately there. Then I have pi over 2, which is 1, so that's right up to here because it's straight up to the top. So that height goes there. Now 3 pi over 4, I skipped one in there. 3 pi over 4 is here. So that's the same as pi over 4. So it's going to be the same height here. Actually, I need to put that a little farther over. Let's get rid of that. Because if that's pi, pi over 4 would be about there. Or 3 pi over 4. So that height is the same as pi over 4, so approximately here. And then pi down here is back to 0. Here's pi, so we're back to 0. So you can see the wave starting here. Okay, now if I continue into these other quadrants, the only difference is it's going to be down. So all my amounts are going to be down. So it's going to start down in this area. So basically, you don't have to know how to do that. I just wanted to show you where it came from and how we took values off of the circle and transferred them onto an XY grid here. So what the graph that you really need to know what it looks like, 2 pi is all the way around the circle. So we just drew the wave that looked kind of like that. The next part is going to be the same wave but upside down. It's going to be under the grid because all of them were negative. Okay, so this is basically the graph that I want you to know how to draw for sine. So this is sine x. Okay, now we're going to write some things down. Actually, let's do the cosine graph before we do that. So the cosine graph is going to be similar but different because it's going to start in different places. If I have y equals cosine x, and I do my little grid here, x cosine x, if I choose 0, the cosine of 0 is 1, so we don't start at 0, 0 like we did the other one. Pi over 4 is still 0.71. Pi over 2 is 0, and so on. So if we do that, let's label 1, negative 1. Here's pi, here's 2 pi. So 0, 1 would be the point right here. Pi over 4, let's break this up. Here's pi over 4, here's pi over 2, here's 3 pi over 4. So 0, 1, pi over 4 will be at about 0.7, which would be about here. Pi over 2 is at 0, so it would be here. Whoa. It would be about here. What is the cosine of pi? Well, cosine of pi is negative 1. So we go down to negative 1 and put a dot there. Let's do 5 pi over 4. 5 pi over 4 is in the third quadrant. Sorry, let's make that 7 pi over 4. I want to be in that fourth quadrant. So 7 pi over 4 brings you back up. So what we're going to end up having in 2 pi, let's do 2 pi before we draw it. The cosine of 2 pi is 1 again. Oops, 0.71 was there. Okay, so looking at all these, I have, here's 2 pi was 1, 0.71 was here, if that's 3 pi over 4. Okay, this is 3 pi over 2. That's the halfway point. So regardless, we've got a graph that looks something like that. So that's the cosine wave. So if that's confusing, don't let it confuse you. All you really need to know is that the cosine of x, if I'm at 1, negative 1, I'm at pi, and I'm at 2 pi, you have to know that it drops down, bottoms out at pi, and ends back up at the top. So let's compare that to the sine graph. A little bit different. Sine wave, here's 1, negative 1, pi, and 2 pi. Sine wave starts at the origin and looks like an S. See how this looks, the cosine looks kind of like a C sideways, and the sine looks like an S sideways. So that's how you can kind of remember which one is which. I have a little rhyme for cosine. It says starts out high, bottoms out at pi. So you can kind of remember that. All right, now we're going to write down some things about each function. The sine function, first thing about it is that it has a period, or it repeats every 2 pi. So the period is 2 pi. It repeats, it starts over again. Let me go back a page. If I were to continue this graph over here, the sine wave, if I continue it that way, would just start again. And it would be the same exact wave over again, because we're going to just go around the circle again. So every time you go a distance of 2 pi, you start again and start a new wave. So that's what I mean by repeating 2 pi. Number 2 is that it's an odd function. So the sine of negative x is equal to the negative sine of x. So it's an odd function. Number 3, it's symmetric to the origin, which means if I have x and y, also on the graph is negative x and negative y. It's symmetric, it's mirror images there. Number 4, domain. Remember domain and range? Domain is like your x values, what you're allowed to put into it. Domain is all the reals, any number that you want. Abbreviation for that is a capital R with 2 slashes. Number 5, the range. The range is your y value. If you'll notice, let's go back a page. I only have a range between 1 and -1 on both of these. I never go beyond that. The wave stays between there. So the range is written like this. It says it ranges between -1 and 1. And number 6, the zeros, which is where it crosses the x-axis, cross x-axis, they are at the multiples of pi. So every time you hit pi, 2 pi, 3 pi, 4 pi, and so on, it is a 0, meaning it crosses the x-axis. All right, so that's for sine. Let's do the same thing with cosine. Cosine, it also repeats every 2 pi. It doesn't quite look the same, but it repeats 2 pi as well. Repeats 2 pi. Number 2, it is an even function, so that means if you have a negative value in, it's just like dropping that. Cos even. Go Stephen. Way to go. All right, number 3, the graph is symmetric to the y-axis. That means if you have x, y, you also have negative x, y. So 3, 4 and negative 3, 4, they're both on the graph. Number 4, the domain is the reals again, meaning the graph goes forever because it repeats right and left. Number 5, the range is still from -1 to 1. We're not allowed to go above or below that. But the zeros are different. We cross at different places. The zeros are at the odd multiples of pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, etc. Okay? So those are some things you need to know, the differences between the two. The next thing we're going to talk about is if I have something like this. That negative in front there flips over the graph. Okay, so here's my normal cosine. You need to put all these labels on there every time. 1, -1, pi, and 2 pi. Drawing your normal cosine wave, looks like the C. And if I'm going to do negative cosine, I start down here and go up, and it just flips it over. So that's what happens there. If I have a 3 in front, so 3 cosine x, what that does is it stretches the graph vertically. So instead of starting at 1, I would start at 3 and go down to -3. So my normal wave would still cross through the same zeros, but it stretches. So think of putting a nail in it here, the rubber band, and then stretching it this way, and this way. So that's what happens when you put a number in front. That's basically where you start the wave. And then the last thing, if I had cosine of x plus pi over 2. Do you remember in algebra where this number made it move left or right? But it was the opposite. To move left is actually a plus sign. To move right is a minus sign. So it moves it left or right. So in this case, we're going to be moving the graph left. So here's my normal cosine wave. Get used to doing this every single time. So normal cosine wave looks like this. Now I want to move it to the left, pi over 2. Well, if this is pi here, this would be pi over 2. Let me get that back. Here's pi over 2. So I want to pick up and move that entire graph left pi over 2. So I'm going to take each point, see these critical points here, and I'm going to move them over pi over 2, every one of them. And then I'm going to redraw it using those points. So I have this. It looks like that. So basically it just moved to the left. So that is it for now. We have more changes to come in the future. Don't forget, Trig love is all around us. Ta-ta for now.